In this lesson, we are going to talk about the laws of exponents, which you have already seen before, but we are going to try to refresh your memory about these laws. The first one that we are going to talk about is any number exponent b. First of all, we call a the base, we call b the exponent, and the whole thing we call the power. So a is called the base, b is called the exponent, and the whole thing is called the power. Now we start with the first exponent rule. Exponent 1. This means that any number exponent 1 is the same number. For instance, 4 exponent 1 is 4. Negative 8 exponent 1 is negative 8, and so forth. That's rule number 1. Rule number 2 is that if you have a number like a which can't be 0, exponent n, this means that a is multiplied n times by itself. A exponent n is a multiplied by itself x times, n times. For instance, 3 exponent 2 is 3 times 3, which is 9. Negative 5 exponent 3 is negative 5 times negative 5 times negative 5, which is going to be negative 5 times negative 5 is positive 25 times negative 5 is negative 125. Next rule is the 0 exponent. This means that any number exponent 0 is 1 except a, the base, cannot be 0. For instance, 2 exponent 0 is 1, negative 10 exponent 0 is 1, and 995 exponent 0 is 1. Any number exponent 0 is going to be 1. The next rule is negative exponent, which is very important. If you have any number except 0, exponent and negative number is the same number as a fraction 1 over, but with positive exponent. So this means that 4 exponent negative 3 is the same as 4 exponent 1 over 4 exponent 3. 2 exponent negative 5 is the same as 1 over 2 exponent 5. The next one is multiplication law. It says that if you multiply two powers with the same base, just add the exponents. This means that if you have something like 2 exponent 3 times 2 exponent negative 1, then this is 2 exponent because the bases are the same 2, and then add the exponents, which is 2 exponent 2. So, as long as a is not 0, if you have two powers with the same base, a and a, add the exponents. The next one is the division law. It says that if you divide two powers with the same base, in this case a, which a cannot be 0, just write one base, which is a, and then subtract the exponents, m minus n. This means that if you have 3 exponent, let's say 4, divided by 3 exponent 1, this is the same as 3 exponent because the bases are 3, 4 minus 1, which is 3 exponent 3. The last law that we are going to cover is called power of a power law. This means that if you have a base like a to the exponent m and then to the exponent n, you just multiply the exponents. This means that 2 exponent 3, exponent let's say negative 2, is the same as 2, 1 base, and then multiply the exponents. 3 times negative 2, which is going to be 2 exponent negative 6. Now we are going to do some examples here. The first one is saying simplify 5 exponent 4 times 5 exponent negative 2. Since the bases are the same, I'm going to write one base, which is 5, and then add the exponents. So 4 plus minus 2, which is going to give me 5 exponent 4 minus 2 is going to be 2. The next example, I'm dividing two powers with the same base. Since the bases are the same, I'm going to write one base, and then I'm going to subtract the exponents. So 2 minus minus 1, which is going to be negative 6. Minus minus is positive, so 2 plus 1 is going to give me 3. The next example, I have power of a power. Since the base is m, I'm going to write m, and then I'm going to multiply the exponents. So 5 times negative 3 is going to give me 5m exponent negative 15. This is a little bit more involved example. We have a series of powers with the same base, all a, but we have to do these step by step. First, I'm going to simplify the numerator. I have a exponent 2 times a exponent negative 5. Since the bases are the same, I'm going to write one base and then add the exponents. 2 plus minus 5. 2 plus minus 5 is going to give me minus 3. Divided by a exponent negative 2 exponent 3. This is power of a power, so I'm going to multiply the exponents. So I'm going to get a exponent 2 times negative 2 times 3 is going to give me negative 6. Now I have two powers with the same base but divided. So I'm going to write one base, and then I'm going to subtract the exponents. So it's going to be negative 3 minus minus 6, which is going to be a exponent. Negative 3 minus minus is positive. So minus 3 plus 6 is going to give me 3. Now I have a word problem which uses exponents. The problem says that the number of hybrid vehicles sold in the US, S representing that number, can be modeled by this formula. S is 199,148 times 2.39 exponent n, where n is the number of years since 2005. It says evaluate S when n is 0. To do that one, if I put n equal to 0 in above equation, I get S is equal to 199,148, 2.39, and is 0 exponent 0. But we know any number exponent 0 is going to give me 1. So 199,148 times 1 is going to give me 199,148. Now, what does the answer represent? It represents the initial value, meaning at 2005, the number of hybrid vehicles in the US was 199,148. Or, if you remember, this is the S-intercept, because S really represents Y. So this is the S-intercepts, the initial value. The second part of the problem says estimate the number of vehicles sold in 2004. We know that the formula is S is equal to 199,148 times 2.39 exponent n. N is the number of years past 2005. Since this is 2004, so n is 2000 4 minus 2005, which is going to be minus 1. So I substitute minus 1 in the equation, I get S is 199,148 times 2.39 exponent negative 1. If you remember, exponent negative 1 can be written as 199,148 divided by 2.39 positive 1 now. If you evaluate this one, this is approximately 83,325.5. So we can say that in 2004, there were approximately 83,325 or 326 cars in US. The next part of the question says, predict the number of vehicles that will be sold in 2007. Now in this case, N is 2007 minus 2005, which is going to be 2. So S is 199,148 times 2.39 exponent 2. Now if you use your calculator and simplify this one, this is going to give you 113,755.3.3. This means that in 2007, the number of hybrid vehicles in US is about 1,137,553.3 or 54 or 55, somewhere in between these two extremes. In this example, I have to evaluate this expression when A is 1, B is negative 2, and C is equal to 3. There are two ways you can do it. Either you substitute the values right away and then simplify, or just simplify this expression first and then substitute. I would prefer to simplify this one first. So I'm going to take the brackets out. So I'm going to get A exponent negative 2B times A exponent 3, B exponent 4. Now, this A exponent negative 2 and A exponent 3, they have the same base, so I'm going to add the exponent. So I'm going to get A exponent negative 2 plus 3 is going to give me 1. B exponent 1 times B exponent 4 is going to give me B exponent 4 plus 1 is 5. Now I'm going to substitute. A is 1. 1 exponent 1 is 1, doesn't matter. B is negative 2 exponent 5. Now, this one is going to give me 1, but negative 2 exponent 5 is negative 2 times negative 2, 5 times. Multiply, and it's going to give me negative 32. The next one is A exponent negative 4, B exponent 5, C exponent 2 divided by A, B exponent 3 times C. Just remember, we want to evaluate it for A equal to 1, B equal to negative 2, and C equal to 3. So I'm going to do the same way. I'm going to simplify first and then evaluate. The first one is that these two, A exponent negative 4 and this A in the denominator, they have the same base. So because it's division, I'm going to subtract the exponent. So I'm going to get A exponent negative 4 minus 1 is going to give me negative 5. B exponent 5 divided by B exponent 3. Since the bases are the same, I'm going to write one base and then subtract 3 from 5. So 5 minus 3 is 2. C exponent 2 and C, again the same base, so I'm going to write C exponent 2 minus 1, which is 1. Now I'm going to substitute. So this is going to be 1 exponent negative 5. B is negative 2, so negative 2 exponent 2, and C is 3 exponent 1. 1 exponent, any number, is going to give me 1. Negative 2 exponent 2 is going to be negative 2 times negative 2 is going to give me 4. and 3 exponent 1 is going to give me 3, so 1 times 4 times 3 is going to give me number 12. The next example is power to a power. A exponent 5, B exponent 2, exponent 3. Again, I'm going to use the fact that I can multiply the exponents, so I'm going to get A exponent 5 times 3 is 15, B exponent 2 times 3 is 6. Now A is 1, so I'm going to get 1 exponent 15 times B, which is negative 2 exponent 6. 1 exponent 15 is going to give me 1. Now, negative 2 exponent 6 is negative 2 times negative 2, 6 times multiply, and it's going to give me 64. The next example is 2a squared b exponent 5. Again, I'm going to distribute exponent 5 inside the bracket. If you do that, you get 2 exponent 5, a squared exponent 5, b exponent 5. So this one goes here, this one goes over here, and this one goes for b. Now, we are going to have 2 exponent 5 times a exponent 2 exponent 5 is going to be a exponent 2 times 5, which is 10, b exponent 5. Now, I'm going to substitute the values. A is 1, and b is negative 2 exponent 5. Now, if you use your calculator, this is 2 times 2 times 2 times 2 times 2, which is going to give you 32. Now, this one, negative 2 times negative 2 times negative 2, 5 times, you're going to get negative 32. And this one is going to give you 1. 32 times negative 32 is going to give you negative 10, 24.